Okay, so we have this question where we want to rotate the coordinate axis so that we eliminate the cross product. So after doing the rotation, the next part is identifying the conic section. And after you've identified it, then you can perhaps sketch the conic section. So our goal right now is to see how we rotate and then identify. So how do we do the rotation? Well, the first thing that you want to keep in mind is you want to substitute for x and y. What are you substituting? You are going to use those equations that relate small x to capital X and also small y to capital Y. In other words, this is the XY, the normal XY plane. It's like you have the XY plane, something like that. And then you have the rotated ones. So this is the X and the Y. And then capital X and capital Y are that's the rotated coordinate axis. So that is the rotated coordinate axis. Capital X and capital Y. Now, those relations, I hope you guys remember them. So that is the angle of rotation, theta. So the relations we're going to use are x will be equal to the rotated x axis, x coordinate, and then you have cos the angle of rotation minus y, and then you have sine the angle of rotation, and then the original x, or y I mean, and then here you have x. Now this is sine theta, this is now plus, then you have y cos theta. I keep writing these because I want you guys to commit these to memory because they're going to be used every now and then. And then when you have to now make capital X the subject, you know to say it will still be exactly the same cos and sine, but now it will be small x cos theta, and then the term that has the sine, will change signs here. So if this is minus, it will now be plus, and this will be y, and it will be sine theta. In the same way, capital Y, now see that sine is here, the trig ratio sine is there, so its sign will change to minus. And then this remains. So this is if capital X and capital Y are the subjects. But when eliminating the cross product, in most cases, you'll be given an equation where it's small x, which is in the equation, small x is small y, meaning that we are substituting these equations. If the conic section was presented in terms of capital X squared minus root 3, capital X, capital Y, plus 2, and then capital Y squared is equals to 1, it would have meant that you're now plugging in these, because you would have been plugging in for capital X and also for capital Y. Okay, enough with that. Let's go on to work out the question. Okay, so to solve the question, the first thing that you need to do is find what the theta is, the angle of rotation. And to find the angle of rotation, we did come up with that relationship. And the relationship was cot 2 theta is equal to, you had A minus C over B. So this is the relationship that helps us to identify what the angle theta is. So in our current case, you know to say A is the coefficient of the x squared term. In this case, A is 1. The coefficient of the x squared term there is 1. B is the coefficient of the cross product. In this case, the cross product is here. So its coefficient is minus 3. Remember, this has to be plus, so this minus is coming from the coefficient. So this is minus root 3. Next up, C is the coefficient of the y squared term. So even if they're not properly arranged, you have to first arrange them in this way and then identify the coefficients. C is the coefficient of the y squared term, which will be 2. So you have 1, 2, and root 3. So you have 1 minus 2, and then over minus root 3. From here, you have, from the numerator, that's minus 1, from the denominator, minus root 3. So that in the end, you have cot 2 theta is equals to 1 over root 3. Now, once you are here, you now need to identify the angle. Now, there are two possibilities. Either you are dealing with a special angle, as in this is a solution of a special angle, or it is not. If it is, then the problem is straightforward. If it is not, there is a trick that you can use. I'll show you guys in the upcoming example. But if it is, let's see if this one is. Can you guys identify if this is a solution for one of the special angles? Is it for sine, for cos, or what? Perhaps before, maybe I give you guys a chance for that. I know to say root 3 is involved somewhere in the special angles. So because of that, I want to think that this is a solution to one of the special angles. But chord, we don't really look at chord, but we do look at tan. So I know how chord relates to tan. I know to say that if I had, for me to get chord 2 theta, I must have had 1 over tan 2 theta. So in other words, where there's chord 2 theta, I can put 1 over tan 2 theta. So this is the same as 1 over tan 2 theta being equal to 1 over root 3. So from this, when you cross multiply, you will see that tan 2 theta is actually just equal to root 3. So this is how our expression has reduced. Now at this stage, you can ask yourself, for what angle here? For what angle, or will tan that angle give you root 3? But before we start finding that angle, are we okay with this simplification?
Please, let's go back there on the tan, how the tan came in.
Okay. So how the tan came in. So we ended up with cot 2 theta being equal to 1 over root 3. But I wanted to see if this is a solution to a special angle. But I don't really have the special angles memorized for cot. Remember when I was giving you the special angles, I never had one for cot. I only had for sine, cos, and tan. So I do recall that cot ends up or comes from tan. So I related cot to tan. So if you had cot theta, let me just say cot, let's say cot phi. If you had cot some angle phi, then this can be related to tan in the sense that it is just 1 over tan the same angle phi. Have you got that?
So that's just.
So if you have cot, let's say cot 60 degrees. Cot 60 degrees is the same as 1 over tan 60 degrees. You get, this is how they relate. It's similar to how, let's say, sec. Do you guys know which one relates to sec? So if you had sec theta, this is the same as 1 over cos theta. If you have cosec written as like this, theta, this is the same as 1 over sine theta. So this is where you end up now if you had cot theta. This is the same as 1 over tan theta. Now, in our current case, we had an equation where we had cot 2 theta being equal to 1 over root 3. But we then concentrated on this. We say, okay, this can be related to tan. Based on this relationship, if you have cot some angle theta, that can be written as 1 over tan that same angle theta, implying that if you have cot 2 theta, this is the same as 1 over tan the same angle 2 theta. Have you got it now? Are we okay now?
Okay, so the 1 over root 3, that simply just gets replaced.
No. Remember I said, for me, firstly, we have this relationship. Now,
Yes.
from this relationship, since this is what we are looking at, I then recall that based on this relationship, I can rewrite the left-hand side, just the left-hand side. I can rewrite it in terms of in terms of tan. So I say, okay, my left-hand side can be presented in this form. So that on the left-hand side, now, instead of cot 2 theta, it's the same as me writing tan 2 theta on the left-hand side. But my right-hand side remains as 1 over root 3.
That's clear.
Okay. Now, it's at this stage where I said we can now cross multiply so that the tan now goes on top. And then we end up with the tan being equals to the root 3. Are we okay?
Yes.
Okay. Now that I have tan, and tan, I think I have memorized it sometimes. I'm speaking this more like on your behalf to say that, okay, now I have a trig ratio, which is more familiar. I can then ask myself, what must be the angle here? So that when I get tan of that angle, I get root 3. Do you guys remember? What angle can we say tan that angle gives us root 3? Remember the table of the special angles I wrote? Tan 60. Yes, tan 60. So you can still come up with those from the triangle. This is 30, this is 60 here, and then you have 2 here, root 3 will be here, and then you have 1 here. So I can still show you guys how to come up with the triangles, but I just gave you guys the solutions to memorize. But you can still be coming up with the angles if you want. So tan 60, you not say if the angle here were to be 60, tan 60 will be root 3 because it's opposite of adjacent, should be root 3 over 1. So you said, okay, if the angle here is 60, then this is what you end up with. So therefore, you have the argument 2 theta must be equals to 60 degrees if this is to be true. Based on that, you can now conclude that theta has to be equals to 30 degrees. Have you seen that?
Yes.
Okay. Now, remember I said we wanted to find the angle. Why did we need the angle? So that we can feed it in these equations. Now we have found the angle. It is a 60 degree. No, we divided by 2. It reduced to 30 degrees. So we can now substitute in our expressions. So where there is theta, we'll put 30. Again, theta here, we'll put 30. Same here and there. Now, these equations can be reduced. To reduce these, you have to recall what sine 30 is. You have to recall what sine 30, and also what cos 30 is. Now, what is sine 30? Do you remember? What is sine 30? Yes, half. And then cos 30.
3 over 2.
Yes. So now that you have these two figured out, you can then substitute. Where you have cos 30, you put root 3. Where you have sine 30, you put half. So this now becomes x multiplying, the first one is cos 30, and cos 30 will be replaced by root 3 over 2. Minus, now you have y multiplying sine 30, and sine 30 will be replaced by half. In the same way, this will be x, now it will be sine 30, which is half. And then this will be plus, and this will be cos 30, which is root 3 over 2. So now just simplify this. This can be written as x root 3 over 2 minus y over 2. And this can be written as x over 2 plus y root 3 over 2. Now that we have our expression simplified, the next step will now be to substitute those equations with the angle in place. We're going to now feed them in the equation we were given. So this is not the rotation part. This is how we rotate them. All we've been doing so far is finding the necessary tool to perform the rotation. Now that we have what we need, we can now perform the rotation. Where we have x, we'll put this. Where we have y, we will put this. So let us begin. The first one is x squared, and where we have x, we will put this. Because the x is squared, even this term has to be squared. Then we have minus, this is root 3. X multiplies y, so we'll put x first. And then now we need y. So we'll get y from here. And then we have plus 2, and then we have the y to follow them. Okay, so the y squared there. It has to be squared. And then the right-hand side, that is a 1, so we'll keep it as a 1. At this point, we now have to expand this and then simplify. Expansion just simplifies this expression. So you'll see a few things will simplify later on, but for now, it's going to be a little bit tedious because we're going to do a lot of writing here. So I think we've been expanding slowly, but I'll try to do this a little bit fast. Let's see within what we're. Okay, so this is what we're going to have. Now, the only thing that you have to do now is simplify this, remove the bracket so that you see the parts which are going to combine. So I'm now just going to rewrite this without the bracket, and let's see what we're going to end up. So from here, having reduced up to here, now we just have to find what can combine, what can simplify, what can subtract. And let's see.
Yes, 3x squared.
Yes, 3x squared whole.
That one goes.
So this is going to cancel out. Just subtract to 0. What else?
So the xy root 3 over 2, and that's in xy 3 over 4, that reduces.
Okay. So the xy root 3 seems to show up a number of times. But one thing that you should just get while doing this is, after this stage, the cross product, if you've done this well, the cross product is supposed to disappear completely. So you just have to So let me see if the terms with the y squared are going to that. Yes, looks like they will.
Okay, well, earlier.
Okay. Is it okay now? Okay. So saying the terms with the cross product are supposed to eliminate completely after this stage. So I will get everything that has a cross product. Let's see what will happen to them. So just trying to simplify them and just to see if they will indeed eliminate. If we've done this correctly, this is supposed to, or everything the cross product is supposed to go to 0. So this is this sign, and then this one is sign as well.
Oh,
Yes. And then this also with its sign.
but
Okay. How is it now, guys? Can you guys hear me just fine?
I can hear you just fine.
Okay, great. All right. So this is this one here. And then we also have this one here. So make sure that you get the signs correctly as well. So this is everything that has a cross product. Let's see what happened to them. If we've done this correctly, this is supposed to give us a 0 if this has been done correctly. Okay, let's try to combine them. So when we isolate the cross products, everything that has a cross product, which is this, bring it here, and this, bring it here, and this one here. And then just simply the cross product on clearly the cross product reduces to this, and we see that the cross product will be equals to 0. So again, if you've done this correctly, at this stage, the cross product always reduces to 0. So we can eliminate the cross product and look at what remains. The only terms that remain are this one here, and then what else? This one here, this one here, and this one here. Right hand side is 2, 1. So I have y squared over 4. And then we have 3y squared over 4. Those are going to add up. And then we have x squared over 2. Don't forget the sign. This is plus, everything is plus alpha. And then you have 3y squared over 2 is equal to 1. Okay. So this is only, these are the only terms that are going to survive. So it was important for you to see how the cross bracket dies up, because most of these terms here are the correct, and it was going to determine if we made a mistake or not. But because it reduced to 0, looks like we've done this correctly. So here, of course, you just need to combine the terms with the y. For this is simple. The denominators are the same, so just add the numerators. This becomes 4 y squared over 4. I'll write this one first. Is equal to 1. This is just y squared. And then we know to say for this, we have to write them such as that represent them on the single fraction over 2 becomes 2y squared is equal to 1. And finally, this will be 5y squared over 2 x squared over 2 is equal to 1. And the last part is a mistake anywhere. So let's say denominator. So at the denominator, this is 1 plus 1, which is y squared. And then we are showing, so that is end up giving us 5 y squared. So at this stage, you know how we get rid of this 5? It becomes y squared over what? The y squared comes over what? Y. What quick section is this? At this point, we have rotated the coordinate axis to eliminate cross product. But now the question should continue to say identify the conic section. So after rotating, what conic section is this?
An ellipse?
Yes, this is an ellipse. So we have identified it as well. So the next part now would be sketch the conic section, but we will not sketch this conic section. The goal was just to rotate and show how it works. Any questions here? So for an example like this one, clearly, because we have x and y here, it implies that even if we eliminate the cross product, we will not be able to identify the conic section. We will have to complete the square. But why I picked this example is the fact that we will not be dealing with a special angle. Instead, we will have to use a trick. This is why I picked this one. It's a very useful trick and you guys need to know it. Let's see, how does it go? Just like before, we want to substitute these expressions. So we still want to make the substitutions, but like before, we first need to figure out what the angle is. Now, when finding the angle, we know to say we're dealing with cot to theta is equal to A minus C over B. What is our A? When it comes to this, our A is 73. What is C? Our C is 52. And our B is 72. From here, what will be the difference on top? I think that is going to be a 1 here, and it's going to be a 21. So this is what we have. Now we recall that, okay, cot to theta, same identity we used earlier on, is equals to 1 over tan to theta. When we bring back this, it implies that where there's cot, we can put that. So you can have 1 over tan 2 theta being equal to 21 over 72. So this is where we are now. And then when we cross multiply, we will see that we end up with tan 2 theta being equal to the 72 goes up and the 21 comes down. This is where we are. Now, this is where the trick begins. You see, what we identify, what we observe here is that this is not a special angle. We can't guess what the angle here might be if the solution is supposed to be 72 over 21. If you have a calculator, yes, you can. But the trouble here is you're expected to do this with little or no dependency on a calculator. This is why the next trick becomes useful. Now, I have to say, most students don't really like this trick. So let's see. So I'll ask you guys to really try to pay attention on this one. You see, if you look at where we want the angle, we want the angle in these equations. This is where we want the angle. And why do we need the angle? So that we can identify what cos that angle is, what sine that angle is. That's all we want. So even if we don't know what the angle is, as long as we can find what cos the angle is and what sine the angle is, we would still be okay. Now, how do we do that? Well, here's the thing. From here, we can use the relations of sine and cos. We know to say that, okay, if we had the triangle, here, and let's say this triangle had an angle at the bottom here, now that angle will give it this value here, which is 2 theta. So if this triangle had an angle 2 theta at the bottom, this is the right angle triangle. If that was the case, then by SOHCAHTOA, we know to say that that angle, your tan has to be equal to the opposite of each other. But tan theta has been given as 72 over 21, implying that 72 is posing as our opposite, and 21 is posing as our adjacent. This is how this trick is going to be deployed. Now, based on that, you can then use these two sides to figure out what the hypotenuse is going to be. We know to say the hypotenuse is equal to the square of 21 squared plus 72 squared by Pythagoras theorem. Now, of course, these are big values. In most cases where you have to do this in a test or in an exam, you have to be dealing with small values here so that it is easy for you to evaluate their squares. So these are big values, just get in how it, so don't mind those big values. What is 21 squared? Okay, so we have with root 441 plus 5184. And then we can add this. We get 5, 6, 5. So we get 5, 6. Now, can we get the root of this? Is it possible? Is it a perfect root? Is it? It's 75. So, 5625. Yeah, it is 75. Okay. This question I got it from some assignment, just not even some assignments. Like, yeah, basically some assignment. So they know to say that you can easily evaluate these for practice. So just using this for practice, where you have to do this in your head without a calculator. This would remain either as a sum. Maybe after combining these, you'd maybe end up with just maybe a root 2 or maybe a root 3 or something. But here it reduced to 75. So the hypotenuse here has reduced to 75. Now look at what this allows you to do. If you know the complete triangle where the 2 theta is example, now you can figure out what sine 2 theta is. You know that by SOHCAHTOA, sine is opposite of hypotenuse. The opposite is 72. The hypotenuse is 75. In the same way, you also know what cos 2 theta is. Cos 2 theta is the adjacent, which is 21, over the hypotenuse, which is 75. But what you need is not sine 2 theta. It's not cos 2 theta. It's sine theta and cos theta. Now, how do you work them out? So another problem has arisen. But luckily for you, that is the last one that I have to worry about. So what do you think? Okay. So using these now, using the double angle identities, not the double, the half angle identities, using these identities, that is cos theta, we can then put this. So for example, the first one, this becomes 1 minus 21 over 75. Then this is over 2. And then in the same way, this one here becomes 1 plus, again, it's equal to the theta which is being used. So you have 21 over 75 again. So 21 over 75, and then over 2. Now, notice what these are giving you. Oh, I left one thing here with these identities. Not really just like this. They do have squares here. This is squared here. Sorry for that. You guys forgot to make that correction here. You forgot to catch that omission. Yeah, so we have the squares there. So what this just implies is that since we're saying that you have sine squared theta is equal to 1 minus, that's 21 over 75 over 2. To get just sine theta, you would have to square root both sides. So sine theta will be equal to the square root of 1 minus 21 over 75 over 2. You'd have to simplify this into a single fraction and then introduce the square there as well so that you can now write it properly. For example, I'm trying to do this a little bit quick. For example, that top part, that's 75 there. And then this would be 75 minus 21. And then all this divided by 2. This is what you're looking at. And then the difference there, that is going to be 54 over 75. And then this is divided by 2. You guys can correct me since I'm doing this a little bit quick. Divided by 2. And then this becomes root 54 over 150. And then when you half, divide everything by 2 there, this becomes root 2 here goes 2 into 5 goes twice, remainder that 27 over 75. So this becomes what sine theta is. So the idea here is you find an expression for sine theta. You find an expression for sine theta, and then in the same way, also from this expression, you also find an expression for cos theta. It will be equals to something. Once you have the two expressions for sine theta and cos theta, you can then bring those expressions and substitute them in here. So where there's cos theta, you can put whatever that is. Where there's sine theta, you can put it here. In the same way, put here and put there. Using this approach, this is a trick that we use for those questions which tend to be a little bit tricky. And as you have seen, what they do is they give you what sine theta is and what cos theta is without really having to find what theta itself is. So you won't find the angle theta. Instead, you find what sine theta is and what cos theta is. I'll try to look for a better example where you have small angles, small numbers to work with, so that you guys can try to play with that one. But I think this is all we're going to do so that we can prepare for the next class. Any questions up to here?